I'll call it S of t.
Should we write this down or?
It's just a review, it's up to you if you wanna write it down or not. I'm gonna call this a position function. And, I don't know, maybe a negative 4.9 t squared plus 17 t plus 8. Okay, so that'll give you a position at any time t for 1 second. Okay, so if I put 1 in there, I'd have a negative 4.9 plus 17 plus 8, and I'd get, I think, like 20.1 feet. Is everybody okay with that? That's how high off the ground it is. Okay, everybody with me on that? Am I able to come up with a velocity function in terms of t? Audrey, you were saying yes. Can you tell me how to do it?
Take the derivative of s of t.
So if I take the derivative of s of t, and if I do that, I would take 2 times the negative 4.9, I think that gives me a negative 9.8 t plus 17, okay? Would I be able to figure out when that object that's falling is at rest? It's not moving. Owen, you're saying yes. How would I do that?
When the velocity is 0.
When the velocity is 0, correct? So this derivative, I could have also called it v of t, correct? Velocity. And I could make that equal to 0. And I would solve for that. And I subtract 17, then I divide by negative 8, so it's whatever 17 divided by 9.8 is, correct? And I could do that on my calculator. And at that particular time, that object is at rest. Would everybody agree? Can I figure out the acceleration?
Wait, wouldn't that be 17? Wait, never mind. I just realized.
I'm okay?
Yeah, I thought you were missing the negative sign. Yeah.
I subtracted.
Yeah,
and
that's what I
divided
was,
by. Okay.
yeah.
Okay. Is there a way I could figure out acceleration?
No, not derivative. Yes, and
I'm taking the derivative again? Would
Yeah.
people agree with that? So the second derivative of the position function, which is the first derivative of the velocity function, which would give me my acceleration function in terms of t, would be a constant negative 9.8, correct? So if I put 1 in here, it'd be a negative 9.8. If I put 1.5 in there, it'd be a negative 9.8. Would everybody agree with that? Okay, that makes sense to everybody? Now, if I asked you how to determine when it would hit the ground, what would I do? Audrey? I would make the position function equal to 0. I would put this in my calculator. I would probably I would put it into y1, I'd graph it, and I would find out where it hit the x-axis,
Where'd you
correct?
get that 18 from?
Oh, it should have been 8. Mistake, a typo. Okay, or a righto, however you want to
We
say
did
it.
the little
Okay. Would everybody agree with that? You could solve that on your calculator?
Mm-hmm.
Okay, so, in fact, let me do that. And it was a negative 4.9 x squared plus, I think, 17, am I right? Plus 8. If I draw it, ooh, and right here, it looks like, right, it's a parabola, it looks like that's where the time would be, correct? And so I'm going to do that on this machine. It's called a rut. Here's my first one, I don't want that because that's negative. So it's about 3.889 seconds. Would you agree with that?
Mm-hmm.
So I would have, this would be my work, and then I would say T equals 3.889 seconds. Can I determine the velocity when it hits the ground? Tyler, are you nodding, or is your head still? I didn't see. You're nodding? How would I do that?
3.889
Into here? My velocity function?
Yeah.
So put this into put that into my velocity function. So I'd have a negative 9.8 times 3.889 plus 17, correct? Everybody agree? So, get out of here. And I'm gonna go at negative 9.8 times my answer, that'll give me the plus 17. And so, I hope that was my answer. Maybe that's not my answer. I know that's not my answer. Times, I wanted X here, I think. X was my answer. And so, it's a negative, this is wrong. This is the correct answer. So it's a negative 21.114 is the velocity. Why is it negative?
It's going down.
Because it's going down. What is its speed?
21.114.
It's just the positive value of that. Would you agree? Okay, everybody kind of on the same page with that? That kind of makes sense? All right. All right. I think we were working on these notes, correct?
Mm-hmm.
And we were coming here, and I drew just a straight line, and it's a velocity, and we said since it's, I think, Joe and I was talking to you, correct?
Yeah.
And since it is above the axis in this interval right here, V of t is positive. Would you agree? Okay? And you said its acceleration is negative because of the straight line. If I took the derivative of this, I would get this negative slope as the derivative. Would everybody agree with that?
Okay, so how is V of t positive again?
It's above the x-axis. Because this is a graph of V of t. This is t over here, this is V of t is my y-axis.
Confused.
Okay, this is the first quadrant. Aren't all my y values positive?
Oh, yeah.
And my V of t is my y value? Okay?
I think I get it.
Okay, good. Okay? I'm gonna ask him another question. Okay, and then I'm gonna ask you. Okay? Here's my question. What is its velocity right here?
0.
0. Would everybody agree? I'm gonna ask you another question. So I lied to you. What is its velocity here?
10.
10. Would everybody agree? Here it's 10, here it's 0. So this particle from in this interval where the velocity was positive and the acceleration was negative, it was speeding up or slowing down.
Slowing down.
Would everybody agree? It went from 10 to 0. You can't be any more than slowing down, right? So in here it's slowing down. Okay, this is a negative 10 Kelvin, correct? Velocity. Here it's 0, here's a negative 10, okay? Velocity, is it positive or negative under the x-axis?
Positive or no negative?
Which one? It's the y values, correct?
Yeah.
This is the fourth quadrant, right?
Mm-hmm.
The y values down below this x-axis, are they positive or negative?
Negative.
Negative. So my velocity, which is my y values, is less than 0. And the slope didn't change, did it?
No.
So the acceleration, which is the derivative, is still that negative number. Everybody agree with me?
Hmm?
Okay, everybody with me?
So it's still negative. The A of t due to the fact that it's going that way.
Because it's a straight line, its slope is negative,
Okay.
and when I take the derivative of a line, I get the slope. Would you agree?
Okay.
And
yeah.
so it's negative.
So the slope of a velocity function is the acceleration.
Correct.
Okay.
So the signs are both the same. Would you agree? Okay, now, Alan, what is its velocity here?
0,
What is its velocity here?
-10.
-10. So its speed went from 0 to 10, correct? Is it slowing down or speeding up?
Speeding up.
Speeding up. Okay, everybody agree? All right. Here's velocity function. Here's time. Here's a -10. Here's a +10, but I'm drawing this one. Is that better? Okay. I know he's a big guy. So, I'm done with it. Okay. Ellie. Ella, sorry. What is its speed here?
10,
What is its speed here?
0,
Slowing up or speeding down? Slowing down or speeding up?
slowing down.
Okay, velocity, is it positive or negative?
Negative.
Negative. Acceleration, is it positive or negative?
Positive.
Positive, because I got positive slope. Would everybody agree? All right. What is it here?
0,
What is it here?
10.
Okay. I'm going to say it correctly. Is it slowing down or speeding up?
Speeding up.
Speeding up. What can you tell me about the velocity?
It's positive.
What can you tell me about the acceleration?
It's also positive.
It's also positive. Okay? You will get a question, I guarantee you, where they're going to ask you, is the object, is the particle, is the person, is the activity slowing down or speeding up? You have to look at two things. You have to look at velocity, and you have to look at acceleration. They may give you a velocity function, and you may have to take the derivative on your calculator of a velocity function, which you all should be able to do, correct? And right here it says speeding up or slowing down. If the velocity and acceleration have the same sign, in other words, if they're both positive or if they're both negative, you just have to say, you have to show the number and say, because they have the same sign, the particle is speeding up. If they have different signs, if one's negative and the other one's positive or vice versa, it's slowing down. Okay on that? Now, they love giving you in a table. Notice here's your t. This is back in time. This is your velocity at these different times. Here's your acceleration at those times. So, let's look at this. The particle here, is it speeding up or slowing down?
Slowing down,
How do you know?
because the signs are opposite.
The signs are opposite. What did I write here? Make sure I read it correctly. Colin, what about here?
It's slowing down.
For the same reason, correct?
Yes.
Ben, what about here?
Speeding up.
Very good. And Austin, what about here?
Speeding up.
Speeding up. Alrighty. Now, watch this very carefully. I'm gonna count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's say that each of one of my steps is a yard. Okay, how far did I walk?
A lot?
Let's say I took 9 steps this way and 9 steps back. How far did I walk? 18. That's exactly correct. That's my total distance I walked, correct? Now I'm gonna give you a word, displacement. From where I started, how far away am I?
0.
0. Would you agree? Because I'm back where I started. Now, if I had done this, let's say I walked 9, touched the door handle, came back and walked this way 6. Now I've walked a total of 15, correct? But my displacement from how far from where I've started is what? 3. Is that kind of making sense? So what we say displacement is the net change in position. So I drew a little picture. So here's my picture. I started here. I go 100 centimeters in this direction, and then I turned around and went back 75 centimeters in that direction. I have a displacement of equals what? So I went 100 this way, back 75, 25. Doing okay? Backside. Okay, so it says the position, the x-coordinate, of a particle moving on the x-axis is modeled by this function. So there's a particle that's just sliding around on the x-axis. Okay, you kind of got the idea? It's going back and forth. And where x is measured in centimeters and t is measured in minutes. Find the displacement for the first 2 minutes. So how would I do that? What do I need to know first?
The beginning position.
The starting position. Would everybody agree?
Mm-hmm.
How do I figure out the starting position?
Put in 0 for T.
It's because that's where it originates. Right, where are you right when the clock starts, correct? Are you an older brother? Are you an old, no, you're younger. But you have an older brother.
Yeah.
Do you remember when you were smaller than him? Okay? And sometimes you would run and he would give you a head start. And so then he would say, go, because you're going to kick, he was going to do something to you. Okay? Right? And he said, I'll give you 3 feet head start, you better go now. That's when the clock started. Would everybody agree? So what I'm going to do is I'm going to plug in 0 into here, and I'm going to get what?
3.
3 what? Because they give you units.
Centimeters.
3 centimeters. Okay, everybody agree with that? So the starting is at time 0, this particle is at 3 centimeters. What do I do next?
You put 2 in for T.
I put 2 in for T. And I got 8. 2 squared is 4. 4 times 4 is 16. plus three. 8 minus 16,
Negative
negative,
five.
what?
-5.
Negative 5. So started at 3, 2 minutes later at a -5, right? It's on the other side of 0, 5 centimeters. So what is its displacement?
-2.
No. It's going to be x of 2 minus x of 0. And I'm going to get -5 minus 3, I'm going to get -8. What does the -8 mean? It means something. Yes, sir.
Is the average rate of change between the 2 points?
It would be if I would divide. So I'm at, here's 0, right? And it's at 3 centimeters, correct? And 2 minutes later, it's now over here, 5 centimeters to the left of 0, correct? Well, the distance is 8, right? 3 to 0 and then 5 more to a -5, correct? But in math, we throw in that negative number to indicate something. Well, okay, what word would we use? You're right, it is going backwards. So here's the number line, right?
Oh, it's decreasing.
Opposite.
Yeah, all those are correct.
Direction.
What direction? Exactly, what direction? Remember, it's on the x-axis, so we have directions here, right?
Left.
To the left. So this means 8 centimeters left. Okay? Because displacement can be negative. Distance can't. Okay? Find the average velocity, okay? So on, I'd have that x of 2 minus x of 0, and I would divide by what?
-5 minus
2 minus 0. Over here, I'll have a -5 minus 3 divided by 2, right?
3. Yeah.
This will give me
-4.
a -8 centimeters over 2 minutes, or a -4 centimeters per minute. It means it's going to the left because it's negative. If it's positive, it's going to the right. What's the velocity at t equals 4? Grace, I haven't called on you. I am sorry, I apologize. What do I have to do to figure out the velocity? Okay, take the derivative. And what is the derivative of this? 3t what?
Minus 8t.
3t what?
3t squared.
Okay, you probably said and I didn't hear you. Minus
8t.
8t. And then what am I going to do with that?
Plug in 4t.
Plug in 4. And when I plug in 4, I'm going to get 3 times 16 minus 8 times 4. Would you agree? I think this is 48. I think this is 32. I think you get 16 what?
Centimeters
Per
per minute.
minute. In the context of the problem, what does it mean?
Right. Wait, no, that's that's for the position.
At 4 minutes, the particle, exactly at 4 minutes, this particle is moving,
And
right,
it's
Audrey?
Moving.
Moving how fast?
At 16 centimeters a minute.
I think you said 16 centimeters per minute, correct? Now, at 4.1, it'll change. At 3.9, it'll change. But exactly at 4 minutes, that is how fast it's going. That is velocity. All right, Colin, how do I figure out acceleration?
You take the derivative of
Okay, tell me what the derivative is.
6t
minus 8, okay? And then I'm gonna put in what?
4.
4 is equal to, do you see where I get 24 minus 8?
Yes.
And, oh, I get 16 again. Every answer must be 16 in this problem. 16 what? Colin?
Mi-
Centimeters per minute squared.
Perfect. Centimeters per minute squared. Very good. Very, very good. All right, Matthew. We have the velocity at 4 minutes, correct? You see it right here?
mhm.
We have the acceleration at 4 minutes. Is this particle speeding up or slowing down?
I would like to say it is speeding up.
Speeding up since what?
Since the signs of both the velocity and the acceleration at the time interval of 4 minutes is the same.
Okay, you said it perfectly. And EFT, I'm just gonna rewrite it because I'm on a roll here. EFT and AT are the same sign. And now you better say t equals 4. Because maybe at 4.1 they're different. Maybe at 3.9 they're different. Okay. Great, now we got a picture. Notice this is a velocity. It says the velocity function, which I will call x of t, is moving on a coordinate line, and so these are the velocities of the velocities, okay? So right here at 0, the velocity is 2. At 2, the velocity is a negative 2. Has everybody got the idea? All right. When? Ben, is the particle moving right? Remember, velocity gives you two things.
2 to 6.
2 to 6. 2 to 6. Here's 2. Here's 6. I got negative velocity, right? At 2,
I see.
right? Negative would mean I'm going left. At 6, I have a positive velocity, so I am going right at 6, but not at 2.
You're like what? 4 and is that 3/4 to 7?
Well, we gotta know what that number is, right?
Yeah.
Poopity poop poop poop, okay? So we'll figure out that number. This is called a what? A line, okay? It has slope, right? Would you agree? So I can figure out the slope. 1, 2, 3, up, 1, 2, 3, 4 across, right? The old-fashioned way. So I got 3/4. T, it's t, right? T minus something. Do I know this point?
Yeah, 6, 1.
So I could say minus 6 plus 1. Would you agree?
Yeah.
And I want to make it equal to what? What's y right here?
0.
I want to make it equal to 0. Does that make sense to everybody? All right, so I'm going to do a little algebra. You see where I get 3/4 t? Do you see where I get a minus 18/4, Ben?
Yep.
Plus 1. 0 equals 3/4 t minus, okay, this is a minus 9/2 plus 2/2. I get, do you see where I get 3/4 t minus 7/2? Are you okay with that?
Yep.
So that means 7/2 is equal to 3/4 t. I multiply by the reciprocal. Are you okay with that?
Yeah.
I got 14/3.
14/3. Perfect.
I did it a different way. I just divided by the 3/4 from a -1.
Okay. There's always a better way. Okay, so 14/3, correct? So you're going to tell me from 14/3 to 7, Ben?
Yeah,
Any place else?
yeah, from 0 to 1.
And 0 to 1. Why? Since what?
Since it's positive,
What is positive? And don't tell me it. The only it I know is from the Addams family.
time is positive.
Oh, you're talking about my cousin
Y
it?
value is positive.
What?
Y value is positive.
What's the name of Y?
Positions. Velocity.
It's velocity. Since v of t is greater than 0. That's my justification. Where are you? Tell me where it's moving left.
So
1 to 14/3. You sound a little tentative, but that's perfect. Good. Why? Since
the velocity is negative.
the velocity is negative. Okay on that? Okay, when is the particle's acceleration positive? Austin, do you have any idea when it's positive? The acceleration. This is a velocity graph, correct? Right?
Yeah,
And what's the relationship between acceleration and velocity?
isn't it just the derivative again?
It's the derivative, correct?
It's the slope.
Or it's the slope of these lines, correct?
Yep.
Because this is a line here. In fact, Ben said this slope is 3/4, right? So here's my equation. If I took the derivative of this, I would get 3/4. Would you agree?
Mhm.
Okay. So from here to here, it's 3/4, correct? From here to here, it's positive. Would you agree?
Yep.
Okay, so it's positive from here to here. So what am I gonna put in there?
2,
For what?
is it 14/3 again?
Well,
Or is
keep,
it 6?
it's gonna go all the way to here, right?
6.
6. Everybody okay with that? A of t greater than 0. Okay? Where is it negative, Austin?
Be 0 to 2,
0 to 2
and from 6 to 7.
and 6 to 7. Because A of t is less than 0. Okay? So you got this one, you got this one, correct? Now, what would it look like if it's 0? It'd be, I'll give you a hint. If this was somebody's heartbeat, you'd be okay with it.
If there was a, was that when there's a hole?
No. Okay. When would you have, acceleration of 0? Yeah, what do you think? When it's what?
When the lines collide.
Let me ask you this. You drive? Do you have a car? Does it have cruise control? Ever use it? I use it, you know when I use it? I use it when I head towards North Dakota. Because like there's nothing there. It's flat, correct? And so I'm always going at that constant speed, right? Or that constant velocity, correct? My foot is off the gas pedal. You know what the name of the gas pedal is called? Does anybody know what you call the gas pedal on your car?
The accelerator?
The accelerator. That's exactly what, correct, because you can accelerate, right? When you depress that pedal. Are you depressing anything when you get it on cruise? No. The acceleration is what? The acceleration is what? You're not pushing on it. It's 0, would you agree? And you set the cruise because I know you follow the rules at 70 miles per hour, right on the dot, correct? And so a half hour goes by, how fast you going? Another 15 minutes goes by, how fast you going? Okay? So what does that look like?
Is it when it's flat?
It's when it's like this, horizontal, flat. Is there any place on this graph that's flat? No. If you jammed your eye on it, it would poke your eye out. Right? There's pointy parts. Does that make sense? All right. Now,
Did you write anything for? the
0? None.
I would have thought 2 and 6, if you look close enough, it might have become a curve.
That's because I was messing around with my notes. No, they're pointy. Okay. When does, Audrey, the particle have the greatest speed? T equals what? I think I heard you. 0. And what else? Did you say 2? Why are you allowed to say 2?
Because the speed is also 2, it's just in the,
Right, it's the absolute value of the velocity, correct? So you, yeah, both of them are 2, they're just going in opposite directions. Alrighty.
So what I see is basically from 0 to 2, the line is the steepest. Therefore, it is the fastest.
What is?
So on the graph from point 0, from the x value of 0 to the x value of 2, it is the steepest. So it's going the fastest. Or am I wrong?
I think I could have moved that point over to here, and it wouldn't be as steep, but it'd still be 2 and it's because -2 and 2 are the same absolute value. Because those are velocities.
I'm confused now.
Okay, the velocity here is 2. Would you agree?
Mm-hmm.
What's the speed? 2. Here, the velocity is a -2. But what's the speed? 2.
So why did you put 0?
Because at time 0, it's going 2, and at time 2, the speed is 2.
So basically the highest and lowest points are the highest speeds.
As long as this speed, the absolute value of this value, y value, is the same as this y value, you can say that.
Confused now, but okay.
Okay, so what's the absolute value of a -2?
2.
What's the absolute value of 2?
2.
What if it would have been here at -1? The speed would be less than this one.
Yep. So would that top speed then be at 0? Would that top speed be different then?
Well, it'd be at 0, but it wouldn't be at 2. Okay?
Okay.
Okay.
I think I get it.
All right. So, Owen, when's the particle speeding up? What do I have to look for?
Anytime the y value is going away from the x-axis, so it'd be,
Oh, okay, I see what you're saying. Okay. Because you know here the velocity is 0, correct?
I think,
Oh yeah, it's a velocity.
well, no, I can't see where you're connected.
You're the same graph, don't you?
Yeah.
Right. So it's moving away from the graph, correct? All right. So you would give me what interval? Or intervals?
1 to 2,
1 to 2.
and then 14 thirds to 6.
14 thirds to 6. Okay, now, you can't say because it's moving away from the graph, okay? Because you're gonna get different graphs, okay? You have to say it in terms of the velocity and the acceleration, okay? So with this one, what can you tell me about the velocity from 1 to 2?
It's increasing in the negative direction.
It's less than 0.
Oh, yeah.
And what can you tell me about the acceleration from 1 to 2?
It's constant. Or no.
You're right, okay, but I want in terms of whether it's positive or negative. What you're saying, here's what's happening, Owen. Everything you're saying is correct, but on the AP exam, they want you to say it in terms of the signage, positive or negative, of the velocity and the acceleration, okay? And you're right, you're interpreting it correctly, and I don't want you to lose that. I'm just trying to guide you to, hey, is one positive, one negative, okay? So, is the acceleration also negative?
Yes.
Yeah, because it's got a negative slope, correct? Okay, perfect. A of t. What about over here? Does it have the same reason? Because you said it's from 14/3 to 6, and you are correct. And I like how you said, hey, it's moving away, it's a velocity function, and because of the velocity function, if it's moving away from 0, right, the x-axis, it's got to be speeding up, okay? I got that. But you're not always going to have the velocity function, and I want you to, in terms from here to here, what can you say about the velocity?
It's positive.
It's positive. And is the acceleration also positive?
Yes.
Yes. And what I could have said, to make it briefer, is in these intervals, the acceleration and the velocity have the same signs. Okay? You don't have to be really specific. All right, slowing down. Maria, where is it slowing down? My guess, Owen said, as it's moving towards the x-axis, correct? So where is that, Maria?
Two to 1.
2 to 1, you're going backwards. 2 to 1. Here?
Oh,
0, right?
Yeah.
0 to 1. Okay? Right? You would see that the velocity is positive and the acceleration is negative. Where else?
From 2 to 14
2
thirds.
to 14/3.
And 6 to 7.
And 6 to 7. And you can say, since B of t and A of t have different signs. Okay? Okay, I got one more thing I wanna go, and then I'm gonna be done talking, okay? And tomorrow's a work day. All right, so we got other rates. And so to know whether something is increasing or decreasing, does anybody have an idea how we can check to know whether something's increasing or decreasing? Check the what? Yes.
Slope,
Okay, what do we call that?
derivative.
Derivative. Okay? So height is increasing if what? The derivative of the height, and this is the way I'm gonna write it,
Height prime.
height prime is what? I look at it, and I look at its sign, and, yes, positive, excellent. Velocity, v prime of t, which is acceleration, if it's decreasing, it has to be
Negative.
negative, less than zero, awesome. Somebody's IQ, you'll look at the derivative, and if it's increasing, it's going to be positive, right? And I got a little smiley face here. You look at its derivative, if it's decreasing, it's less than zero. Okay, recall, derivative on a calculator, absolutely fantastic. So get out your calculator. We're gonna put in into our graph 5 to the power sine of x. If you have, you know, use that upside down V, right? And then parentheses sine of x, if you want to do. All right, now, I'm gonna go back to my menu. And for TI people, you're gonna go to your math button, correct? Right? And I think is it 9 or 8?
8.
8. Go to 8. Get y1, comma x, comma what? 3. TI people, you're gonna go, not TI, Casio people, you're gonna go to option. Oops, I gotta go get up here. Go to option. Go to calc. Find your derivative. Go to vars. Choose graph. Hit y, 1, and then a comma. If you got an older one, and then put a 3 in there. And did you get that as an answer?
Yes, but I got I did that your way, but I also did it my way by just going to the table because mine shows me my derivative.
That is A-okay. Okay, you can do it that way too. Okay? So I'm gonna write that f prime of 3 is equal to, if I round, I got a -2. Would everybody agree with that? All right, it says, is the function already a rate of change? If f of x is the bunny population after x years, what is f prime of x? The what? Yes, sir.
The rate of change of the bunny population after or during a certain during a specific amount of years.
The rate of change of the bunny population and I'm just going to write pop here, per year. F of x is the rate at which the bunny population increases, bunnies per year. So what is its derivative? So I changed it to a rate. So what's it going to look like? Remember, f of x is equal to bunnies per year. So what's f prime going to be? Matthew?
Bunnies per year squared.
So the rate of change of the rate of change. Would everybody agree? All right. So, this is kind of a little review. Here we have number of people after so many years. I want to know P prime of 15. How would you do that? Notice there's no 15 up there, is there?
Would you take 150 minus 120 over 20 minus 10?
You would do that exactly, okay? So I'm gonna write it just kind of this way, P of 20 minus P of 10 over 20 minus 10, and you get, I think you said 150 minus 120 over 10, right?
Yeah.
And that 150 minus 120, is that 30? 30 divided by 10? Look what the answer is. 3. 3 what, Austin?
It'd be 3 people per year.
3 people per year, perfect. So this is positive, correct? So that means P of T is increasing. Everybody okay with that? All right. This one's a tad different. This one, you have 3 choices. Either of them is acceptable. The reason why, they give you 20, don't they? So, P prime of 20 could be configured this way. And it would be P of 30 minus P of 10 divided by 30 minus 10, which is kind of what you did before, right, Austin? Or you could do it this way. P of 20 minus P of 10 over 20 minus 10. I wrote a 1. So I'm using these two right here. Or you could do it this way. P of 30 minus P of 20 over 30 minus 20. When they give you a value like that, they'll approximate.